Hello student, myself Millie Sankla, and in our subject structure analysis part 1, today we solve the example of thin cylinder. Okay, now here is our first example. In this example, first of all we read the given data carefully and then we check which data we find out here. Okay, now thin cylindrical cell with internal diameter D 1000 mm and thickness of wall is equal to 15 mm, subjected to steam pressure 1.5 Newton per mm square. Find circumferential and longitudinal stress. Okay, first of all write down the given data. In this data, D is given right here. D is given 1000 mm. Okay, and thickness T is given 15 mm. Now next, stream pressure P is given 1.5 Newton per mm square, and find out, first we find out here circumferential stress, right here circumferential stress, and second name of this circumferential stress is equal to hoop stress. So here again we write or hoop stress. Okay, now notation of this hoop stress is equal to sigma c, and equation of this hoop stress is equal to PD by 2T. Now put the value of this P. P is given 1.5, then D is given 1000, then 2 into thickness T is equal to 15. After dividing this numerator and denominator, our answer is 50 Newton per mm square. Now next we find out second here mentioned longitudinal stress right here. Now we find out longitudinal stress. Okay, notation of this longitudinal stress is equal to sigma L right here. Sigma L is equal to PD by 4T. Now P is equal to 1.5, then 1000 and 4, and thickness T is equal to 15. Now my answer is equal to 25 Newton per mm square. Okay, in this example we find out two stresses. First stress is our hoop stress and second stress is our longitudinal stress. In next example we find out change in dimension, and this change in dimension is del D, then del L and del V. Okay, now we solve our next example. Okay, now we solve our second example of thin cylinder. Okay, in this example we read the data properly and then we solve it. Okay, first cylindrical vessel closed with plane end is made up of 4 mm thick. One by one right here. Here thickness T is given 4 mm. Next, external diameter D is given right here. Capital D is equal to 250 mm given, and length L is equal to 750 mm is given. Now it is subjected to internal fluid pressure P right here. Internal fluid pressure to P is equal to 3 Newton per mm square. Calculate longitude and hoop stresses right here. We find sigma L, then sigma C, and also find out change in diameter. Okay, del D, del L and del V, and also here data is given E. E is equal to our Young's modulus 2.1 10 raised to 5 Newton per mm square, and Poisson's ratio mu is equal to 1 by m is equal to 0.3. Okay, now one by one we find the data. First of all we write here, first we find out hoop stress. Write down hoop stress sigma C. Sigma C is equal to PD by 2T. One by one. Here internal diameter D is given, but in this data capital D is given. So first we find out internal diameter. Now capital D is equal to D plus 2 times thickness. Okay, now my internal diameter D is equal to capital D minus 2 times thickness. Now capital D is equal to 250 minus 2 into thickness given 4. Okay, and my small d is equal to 242 mm. Okay, internal diameter D for this thin cylinder is 242 mm. Now put the value. P is given in this data 3 and internal diameter is given 242. Divide by 2 and thickness is given 4 mm, and my answer sigma C is given 90.75 Newton per mm square. Okay, now second we find out longitudinal stress. Right here longitudinal stress. Okay, make a heading longitudinal stress, and notation of this longitudinal stress is equal to sigma L. Sigma L is equal to PD by 40. Now one by one put the values. 3 internal diameter D is equal to 242, divide by 4 and thickness T is given 4 mm, and my answer is equal to 45.375 Newton per mm square. Okay, here we find out our first two stresses, that is our longitudinal stress, and second stress we find out hoop stress. Now next we find out change in dimension. Okay, now first of all our first change in dimension is del D. Now guys, if we find out change in dimension, before change in dimension we find out strain, because equation of strain is equal to change in dimension divided by original dimension. So before find change in dimension we find out strain. So right here our first strain is equal to hoop strain, and notation of this hoop strain is equal to epsilon 1. Okay, right here epsilon 1 is equal to sigma C by E minus 1 by m sigma L by E. Now one by one put the value. Sigma C is equal to 90.75 and Young's modulus is equal to 2.1 into 10 raised to 5. Then 1 by m, that is equal to mu. Okay, 0.3 into answer is equal to 45.375 divided by 2.1 into 10 raised to 5, and my answer of this hoop strain is equal to 3.67 into 10 raised to minus 4. Okay, now this epsilon 1, that means strain is our unitless quantity, so here we can't write a unit of hoop strain. Okay, this is our unitless quantity. Now what is epsilon 1? Epsilon 1 is equal to del D by D. If you remember, in theory portion we covered this. Hoop strain is the ratio of change in diameter to original dimension. Okay, original diameter. Now del D is equal to epsilon 1 into D. Now epsilon 1 we find it 3.67 10 raised to minus 4, and our diameter is equal to 242. Now my answer of this del D is equal to 0.0889 mm. Okay, first we find out, first right here change in, write down change in diameter del D is equal to 0.0889 mm. Okay, now second we find out longitudinal strain. Write down, second we find out longitudinal strain, and notation of this longitudinal strain is equal to epsilon 2. Write down, epsilon 2 is equal to sigma L. Okay, now here first we write down longitudinal stress, sigma L by E, then Poisson's ratio sigma C by E. Now put the values one by one. Sigma L is equal to 45.375 2.1 into 10 raised to 5 minus Poisson's ratio is equal to 0.3 and our sigma c is equal to 90.75 divide by 2.1 into 10 raised to 5 and my longitudinal strain is equal to 8.64 10 raised to minus 5. Now what is longitudinal strain? Longitudinal strain is equal to del L by L. Now we find out delta L here, right here. Delta L is equal to epsilon 2 into length. Now what is the answer of this epsilon 2? We just find out 8.64 into 10 raised to minus 5 and length is equal to 750. Now my delta L is equal to change in length is equal to 0.0648 mm. Okay, here we find out two dimension change. First is our change in diameter. Okay, first we find out change in diameter and second we find out change in length. Now third we find out change in volume. Okay, now what is the equation of this change in volume? Equation of this change in volume we already derive in derivation. Right here, first of all make a heading, change in, write down change in volume. Change in volume is equal to del V. Del V is equal to volume, then 2 times epsilon 1 plus epsilon 2. Now what is volume? Volume is equal to area into length, then 2 times epsilon 1 plus epsilon 2. Now what is area? Area of thin cylinder is equal to pi by 4 d square into L, then 2 epsilon 1 plus epsilon 2. Now one by one put the values here. Okay, pi by 4 diameter, that means our internal diameter, 242 square, L is equal to 750 and here 2 into epsilon 1 is equal to 3.67 10 raised to minus 4. This is my first, and plus second epsilon 2 is equal to 8.64 10 raised to minus 5. After solving this, we find change in volume is equal to 28,324.56 mm cube. Okay, this is our third change in dimension, that is our change in volume, 28,324.56 mm. Okay, in this data we find out three values: change in diameter, change in length and change in volume. Now in next example we solve another example. Just now we stop here. Okay.